Hey there and welcome to week 6. What I want to do in this video is briefly go over the processes of sensation and perception with you all. What I'll do, I'll also add a couple of extra outside source videos into the supporting materials for this week that'll kind of go over the different sense organs and how they act, how they work in detail. But in this video, it's going to be very brief. I'm just going to go over the process of sensation and perception with you all. So, let's go ahead and get started. Sensation is the process of detecting an environmental stimulus and then converting that stimulus into some kind of a neural signal or into neural activity. And the steps of sensation are fairly similar for each of our 5 major senses. So we have sight, we have hearing, we have touch, we have taste, and of course the last one, we have smell. So what happens is that first, a sense organ receives a specific type of sensory stimulation. So in this example, we're going to be using vision. And so what will happen is you'll have light that enters the eye, and then we have these specialized sensory receptor cells. In this case, they're rods and cones that are in the retina. They take that light, convert that into a neural signal, which then can be processed in the brain. And so that whole process is called transduction. This is the conversion of an environmental stimulus into a neural signal. Now, these signals then pass through the thalamus, which, if you remember from chapter 3 in biopsychology, is kind of like a relay station for sensory information. So that signal is then routed to some kind of an area in the brain that's specialized in processing that type of information. So for our example in vision, that information gets sent to the occipital lobe, which processes visual information. And the other senses kind of follow very similar paths. So signals in response to sound, those are sent to the temporal lobe. The parietal lobe processes touch and temperature. And then the gustatory cortex, which is part of the parietal lobe, that processes taste. Now, the only stimulus that this doesn't apply to is smell. And so instead, neural signals for smell, they don't pass through the thalamus. Where they actually go is they pass through the amygdala, which processes kind of is associated with emotion, and then also through the hippocampus, which is associated with memories. And this is one of those reasons why for a lot of people, certain smells can trigger memories for them. All right. Now, the process doesn't really end there because after sensation, obviously, comes perception. And perception is the identification and interpretation of a stimulus. Perception is what we do with that sensory information that we take in, it's how we make sense of the world. And if you think about it, our 5 senses are really our only windows to the world and into the environment and being able to identify and figure out what's happening around us. So whether a stimulus is perceived or not depends on several factors. So there's a couple of issues that come into play when we're talking about our senses and whether or not we perceive certain stimuli. The first issue is absolute threshold of sensation. It's the minimum amount of stimulus intensity that's needed for a receptor to react or a receptor to become activated. So, for example, the absolute threshold for sound would be the lowest volume of a tone that you can perceive. All right, so how low do I need to turn the radio down, or how low can I turn the TV for you to still be able to hear? Right, like what's that minimum volume? And it's going to differ from individual to individual, but what's the minimum amount of power a stimulus needs to have for you to be able to detect it? All right, so that's the absolute threshold. The just noticeable difference, and the book talks about this in terms of difference threshold. This is the minimum change in a signal intensity that can be detected. So what does that mean? Once you've detected a stimulus, how much do I need to change for you to be able to consciously say, okay, there's a difference. I noticed that difference, right? So for example, it would probably be pretty difficult for you to be able to tell the difference between a 50-pound weight and a 55-pound weight, right? Because they're both really, really heavy. However, if I give you a 1-pound weight and a 5-pound weight, you'd probably be able to differentiate between those two fairly easily. And that's what the just noticeable difference or difference threshold is all about. Now, the last issue is sensory adaptation, which occurs when sensory receptor cells responses start to decrease after continuous or repeated stimulation. So this kind of reduces the perceived intensity of a stimulus. And what that means is the longer that you're exposed to a certain stimulus, your senses start to adapt. They get used to that, and it makes it harder for you to actually start picking up that stimulus because your senses are adapting to it. Your senses are saying, "Oh, well, this thing, whatever the stimulus is, it's here, and it's here to stay." So I'm not going to pay attention to it as much. And so, for example, you might easily detect the smell of cigarettes if you're a non-smoker. However, if you are a smoker and over time you're around that smell more and more often, it's very likely that you're going to perceive it less and less. And this is one of the reasons why you can hop into, if you're a non-smoker and you hop into a car with a smoker, you're like, oh my God, how can you like stand this, right? But smokers, they don't notice it because they're around that sensation. They don't even smell it on themselves a lot of times. But you can, if you're a non-smoker, you can detect that smell really, really quickly. And that's what sensory adaptation is really about. And sensory adaptation can occur in any of our five senses. So this is if you go, if you go to get into a pool, or if you're at the beach and you test the water and it's really, really cold. But if you stay in that water, your senses will adapt and it'll actually start feeling really, really warm, right? And so all five of our senses have these adaptations to stimuli that are just around for long enough. Now, there are kind of two ways that our brains process sensory information, either by something called top-down processing or through what we call bottom-up processing. Top-down processing uses what you already know to influence the interpretation of incoming sensory information. And this is what allows you to read the sign even though there's a letter missing. Right, so you're looking at this, you probably identified this really quickly that this is a stop sign, even though the O is missing, right? So it doesn't really say the word stop. But you're relying on your past experiences, your knowledge. You've probably encountered the sign many, many times in your life, especially if you're a driver. And so your brain doesn't really need to focus on every single part of the stimulation that it's getting from looking at the sign. It already kind of knows, oh, I know what this is. I've experienced this before. So I don't need all the information. Even if information is missing, I can identify this. That's top-down processing. But your brain also uses something called bottom-up processing. And this is when it uses all of your raw sensory data to try to create some kind of a perception. Similar to if you're looking at this image here on the right and you're trying to figure out what this image is of, you're probably using bottom-up processing because this is a vague image. And so your brain doesn't really know what it's looking at. So what it has to do is it takes every single piece of information that it's getting and it's trying to piece it together like a puzzle to kind of figure out or try to figure out what is going on in this image. And just to kind of help you out, if you haven't already guessed or figured out what it was, I've highlighted this area a little bit, so maybe that'll help you identify it a little bit quicker. All right. Anyway, thanks for watching and have a great week. Take care.